Thế ba thấy chưa? Okay, we continue. So now come back. So remember that when we investigate the characteristics of synchronous motors, okay, synchronous motors. Yeah, uh, we have the phasor diagram, right? We have the phasor diagram, yeah, for three cases, right? We have leading, yeah, we have lagging, and we have unity, right? So we have the formulas. We have V phase E E A plus R A plus J X F times I A. Remember that this is voltage equation of synchronous motors, which is voltage equation. Voltage equation. So we have the equivalent circuit. This is EA. This is JXS. This one is RA, right? Then we have here is V phase, and remember that for a synchronous motor, we need to supply uh, or we need to inject the phase current IA. That means the stated current IA should come into the stated wire. Okay, yeah, and then we have the torque speed curve, right? Torque speed curve of synchronous motors. So here we have torque, and here we have speed. Okay, you can use omega is 2 by n since divided by 60. Okay, and we know the synchronous speed is 60 fse over the number of pole pairs. Okay, so we can get the torque. Yeah, we can get the torque speed curve like this, right here, and this a and since, and this a rated torque. This a rated torque, right? And we have yes, we have this a pull out. We say pull out, or we say maximum torque. Yeah, this is tau max. Okay. What else? And we also discuss about the effect of large change to the synchronous motor. For example, this is stator and this is rotor, right? The rotor, this is the rotor shaft, and here this is the motor. So we need to supply the power, right? We need to supply three-phase power system. This is IA, IB, IC. Then this is synchronous motor, and then the rotor will be rotated. Okay, so here E, B out. Okay, so B out, E, B rated. Okay, and equal to mechanical power, and this one is B in. So B in is electrical power. Remember that. Yeah. So we have two cases. Yeah, the first one does mean large change. So we have the power output will be increased or decreased. Okay, and we have different kind of load. We have lagging load. We have leading load. Okay, and we have unity load. Okay, so now we consider the second effect. We say the effect of field current. Field current. So for remember that for the first effect, you know, when the load chain mean IA chain, right? IA in read or the read, or input in read or the read. But remember that the magnitude of EA is constant. Why? Because IFE fixed. Okay, IFE fixed, so EA is fixed or constant. Okay, but now look, now we think about we change the field current. So that means IF change. Okay, so what will happen? What will happen? So here, look. Okay, at the beginning of session 3.2, yeah, we discuss about the effect of load change on a synchronous motors, and we also example, right? Yeah, also example. So now we go to the second effect of field current changes. Okay, yeah, field current changes. Okay, so if IF change, what will happen? So if IF change, that means EA change. EA change. Why? Because EA proportional to K phi M omega since. Okay, so if IF change, that means phi M change. Okay, so phi M change, that means IA change. Remember that IA change. Okay, yeah. So when the IF change, the power is also constant. Okay, so the input power is fixed. Okay, so this case is opposite with this one. Okay, for the first case, be in chain, right? IF fixed. So the second one, be in fixed and IF chain. Okay, yeah. So now we analyze this diagram. Okay, so for when we consider the effect of field current field current changes on a synchronous motors, we assume, okay, B is constant. Look, B is constant. Yeah, and we have lagging load. We have lagging load. Okay, yeah. So we have the formula, right? We have V phase is EA plus RA plus JXL times IA. And if we assume RA is 0, you get the V phase EA plus JXSIA. Okay, like this. This is lagging, right? This is V phase with the phase angle 0 degree, and this is IA. So the phase angle here is theta lagging, right? So yeah, so here, yes, So if here EA plus what? Plus JXSIA. This is JXSIA. So the vector EA plus the vector JXSIA, you can get a V phase. Okay, so this is the phase diagram of synchronous motors in case of lagging load. Okay, and then you should remember that the power is constant. Yeah, the power is constant. The power constant. So here, so the first case, IA1, right? This is lagging, yeah, and this is V phase. Of course, V phase is the magnitude of V phase is the phase angle 0 degree. So here you can get EA1, and this one is JXS IA1, right? IA1. So when the field current increase, EA must increase. Okay, yeah, because IF increase mean phi m increase. Okay, so phi m increase mean the magnitude of EA increase. So now we have another case, now EA1 increase, even though EA increase, but the power is constant. Why? Because we have BE3 V phi EA psi delta over XS. Okay, yeah, V phase constant. EA and B constant, right? When we consider the effect of the field current, B is constant. So now B constant or fixed. Okay, and V phase fixed. So, but when we increase IF, that means we increase EA. Okay, XS is fixed. B fixed, V phase fixed, XS fixed. So when we increase EA, we need to decrease psi delta because B is a constant. Okay, yeah. So psi delta decrease if delta decrease. So what does this mean, delta? So delta is the phase angle between V phase and EA, right? So here, look. So when we increase EA, so now we have the new delta here. This is delta alpha comma. This is delta, right? Yeah. So when we increase EA, delta decrease, So that means delta alpha comma less than delta. Okay, and B is constant. So yeah, and if here EA2, so here IA2. Okay, continue. So if we continue to increase IF, okay, you can get IA3 here. Okay, the magnitude of EA3 increase. Okay, so that means here we have delta over double over comma. Okay, so delta double over comma less than delta over comma. Okay, because when we continue to increase EA, delta continue to decrease and decrease. Okay, more and more. Okay, so this is delta over comma. Yeah, delta over comma. Okay, and then here you can get JXSIA3. Okay, so if here EA3, so this is IA3. Why? Because JXSIA3 should be perpendicular to IA3. Okay, yeah, and then continue to increase IF, increase more IF. So you can get here is IA4. Okay, so this one is EA4. Okay, EA4. Then this EA4. Okay, yes. And now you can get delta triple overcomer. Okay, here triple overcomer. And delta triple overcomer should be smaller and smaller. Okay, yeah. So for this is the phasor diagram when we are considering the effect of field current changes on a synchronous motor. Okay, so this one is lagging, right? So if we consider here the x-axis, okay, so at the bottom, this is lagging, and at the top, we have leading, right? Yeah, yeah. Okay, so this one like the V-shaped curve, the V-shaped curve. Why? You know, at the beginning, at the beginning, you know, here is the magnitude of IA, IA1, IA1, and then when we increase IF, you get IA2, and IA2 less than IA1, right? Okay, after that, we continue to increase IF. So now, IA3 higher than IA2. Okay, and we continue to increase IF, you get IA4. So IA4 higher than IA3. Okay, so at the beginning, IH1 is higher and then lower, higher and higher, So this one like V shaft. Okay, IA is increase and then decrease. After that, increase. Okay, so here is V shaft. V shaft. Okay, so we can draw the curve like this, yeah. So we have the relationship between IF and IA, right? Right. Okay, so first of all, we increase IF. That means we decrease IA, right? Look, at the beginning IA1 here. So when we increase IF, we decrease IA1 to become IA2. So if we continue to increase IF, okay, so IA increase again, yeah, IA3 and IA4. Okay, yeah. So sometime IF is proportional to IA. Sometimes IF is inversely proportional to IA. Okay, so you get this curve. This is IF. This is IA. Yeah, and this one is the okay. Yes. So this one is power factor is 1 because the IA2 is in the same direction with V face. Okay, so now we draw the curve. Okay, yeah. We draw the curve. So we come back. One, So now we have the relationship between IA, right, and IF. Okay, yeah. And we have the power factors. This is power factors. Power factor is 1. Yeah. So for lagging, if we increase IF, that means we reduce IA. So for leading, when we increase IF, that means we increase IA, right? It's the key observation. Look, come back. Look, right? This is lagging, right? Lagging. So yeah, at the bottom, this is lagging, and at the top, this is leading. You know, for lagging, when we increase IF, so IA2 less than IA1, right? So for leading, when we increase IF, that means we increase AA, of course, but IA increase. Okay, so look, okay, we have IA4 higher than IA3, higher than IA0, sorry, IA2. So now we come back. Now we come back. You can see when we increase IF, you know, so IA decrease, IA decrease. So we say like it. Yes. Okay. So if we continue to increase IF, IA increase. So this is leading, you know, and this is power factor, right? This is leading, and here at the left side, this is lagging, lagging. Okay. So at the beginning, IF is 0, right? IF is 0 here. This is origin. So if IF increase, IA decrease. Okay. Here up to here, up to here, up to here. That means the power factor is 1. It's a unity. It's a unity power factor. And then if we continue to increase IF, right? IA increase because this one for leading cases. Okay, now come back. Now come back here. This is the curve. You know, this is PF. This is PF. Okay, so IF here is 0. So when we increase IF, look, IA decrease. Come on, decrease, right? Decrease. This is lucky. So up to here, to here. So if we continue to increase IF, you know, now lucky is become leading, and then IA increase. IA increase. Okay. So for different, so for this curve for we have the input power B1, and this is B2, and this is B3. So here maybe here we have B4. Okay, so it depends on different input power. We have different curves of IA and IF relationship. Okay, yeah. So in the lab, okay, Mr. Hill will guide you to do this experiment. Okay, so we need to fix what? We need to fix, you know, yeah, yeah. So you need to for the lab experiment, you need to fix B in, okay, or we fix lot of power B out, okay, and then we increase IF from 0 ampere to higher values, okay. So at the beginning, this is a lagging case. So when we increase IF, okay, we measure what? We measure IA, okay, and okay, and you can see if we continue to increase IF, IA decrease, okay, yeah, add some values, and then we continue to increase IF, okay, and lagging now become leading, so IA increase, okay. So this one we say V curve, okay, for what? For the field of the effect of field current changes, okay, we say V curve. Any question so far? Thấy ba? How about the others? So for the question is, how can we know leading or lagging? Okay, leading or lagging. So in the left we have power factor meter. Power factor meter. So this is the indicator of power factor meter. Okay, so this is lagging, this is leading, and this is unity. Okay, and we have the pointer here. Okay, so if the pointer indicate the left side, so that means lagging. So if the pointer indicate at the right side, we have leading. Okay, so in the left we have a power factor meter, and you can know some cases for lagging and the other cases for leading. Okay, yeah. And here we have some explanation, but I also explain to you. Okay. Mm. So now we consider this slide. We have two phasor diagram. The first one is underexcited. Underexcited. So underexcited for lagging and over excited. Excited. So synchronous motor. This one for lagging. Sorry, this one for leading. Yeah, this one for leading. Yeah, so you can compare. Look, because this is lagging, so AI, right? The magnitude of AI less than V phase, less than V phase. Okay, this one for motor, so we have what? We have V phase EA plus XA RA plus chase XA time IA. Okay, we assume is RA is 0, so you get V phase EA plus chase XSIA, right? Right? Yeah. So for the lag in, the magnitude of AI lags V phase is lag into V phase or smaller than V phase. But now for leading, this is IA, you know. So now we have EA higher than V phase. EA higher than V phase. Yeah. This is the magnitude of AI, then the magnitude of V phase. Okay. Okay. So remember that for the power flow, for the power flow of, I mean the active power flow, you know, the power will flow from the lead-in to the lag-in, right? Lag-in, yeah. So, you know, V phase is always leading AI. Look, V phase is always leading AI, you know, yeah. So the power is always come to the motor. So if here a rotor, yes, and this A I B I C I B I C. So the power is always come to the synchronous motors. Okay, because the power will flow from the lead-in to the lag-in. Okay, so V phase is higher than is leading to AI. Okay, how about Q? Q. Q will flow from the higher voltage, right, to the lower voltage. Lower voltage. Okay, so look at the lagging case. Q, you know, for lagging case, V phase, the magnitude of V phase is higher than the magnitude of AI, right? So they also consumes Q. That means synchronous motor consumes B and Q. Okay, but for this case, look, EA higher than V phase. Okay, so that means this motor Okay, reject, or reject, right? Reject Q, because AI higher than V phase. So if here we have this the circuit, right? Yeah, this is AI, this is the V phase, this is JXS, and this is RA. You know. So for this case, they also consume B. To B comes into the motors, but Q, you know, because the magnitude of AI higher than the magnitude of V phase, so Q go out. Q go out. Okay, consume B and reject Q for over excited synchronous motor. How about this case? How about this one? We have AI, right? And this is JXS. This one is RA, right? And this one is V phase. Okay, so V phase is always leading AI, so B is come in, B come to the motor. How about Q? The magnitude of V phase higher than the magnitude of AI, so Q also comes into the motor. So that means for under-excited synchronous motor, it consumes both B and Q. For over-excited, okay, they consume the B and reject the Q. Okay. Yeah. Any questions? Any questions? Thầy ba. Xuân Quỳnh. Bình. Any questions?
Dạ không ạ.
Okay, so example. Now we have example. Okay, yeah. We analyze this example. Look. Oh, similar, right? Similar the first example. Now we have synchronous motor. Okay. Okay. Yes. Now example 2. We have synchronous motors similar to example 1. We have FSA 60 Hz. We have delta connection, so line voltage equal to phase voltage in magnitude equal to 208 volt. Okay, we have rated parameters. Okay, A 45 HP. Okay, right, 45 HP, and 0.8 power factor lead-in. Okay, do they have 0.8 power factor lead-in? Yeah, so we can get theta E plus 36.8 degree. Okay, yeah, this one. And we also RA is 0, right? And XSA 2.5 ohm. Okay, initial condition. Initial condition, we have B out E, how many? 15 HP. Okay, 15 HP mean 15 times 745. Okay, so 15 times 745, you get 117,111.75 watt. Okay, and 0.8, right? 0.8 lagging, 0.8 lagging. log in. Okay, that means theta is also 36.8 degrees. This is minus. Okay, they also have IF. How many? IF at this condition is 4 amperes. Okay, so yeah, so that means we have IF here is 4.0 amperes. Yeah, sketch the phasor diagram of this motors, phi IA and EA. Okay, so question A. Okay, sketch the phasor diagram, right? Yeah, the phasor diagram and calculate IA. What else? And EA. And EA. No? Yeah. Very easy. We calculate before, right? We calculate before. So now, how can we answer? We need to calculate IA. You know, B in E, B out plus delta B total, and similar to example 1, we have 11,175 here, right? Plus 2,500. Okay. So 1,175 plus 2,500, you get 13,675 watt. Okay, and this is B electrical, right? So we have B in is root of 3 VL IL cosine theta. Okay, this is locked in with 0.8 power factor, so you can get IL, right? E 13675 divided by square root of 3 to 0 and 8 and 0.8, right? Yeah, divided by square root of 3 divided by 2 0 and 8 divided by 0.8. Yeah, so here you get 47.45 ampere. Okay, that is okay. So we can get because we have delta connection, right? So we have IA E IL over square root of 3. So you get 47.45 divided by square root of 3. So you get 27.3 ampere. So now we get IA E 27.3 with the phase angle minus because the power factor lag is minus 36.8 degree. Okay, then so we also get the EA. Okay, EA is EV phase plus RA plus JXSIA, and we calculate before from example 1, you get 254.8 with how many? With okay, so yeah, you need to calculate. Okay, this one is wrong because this one is minus. I'm sorry, I make confusion with singular generator. So this one is minus. Okay, so you get how many? V phase, you get 208 with 0 degree, right? RA is 0, so minus J 2.5. How about IA? This is lagging, right? Lagging. So here we get a 27.3 with minus 36.8 degree. Okay, so you get the answer. With 0 minus 2.5 I times 27.3 with minus 36.8. Yeah, you get 175.8 with minus 18 degree. Okay, so if we compare to the results, yep, a little bit different, but I think that's okay. That's okay because we round up some results. Okay, for example, here it 20 is 85, 80 or 85. Oh, sorry, my mistake. Okay, I understand. Because I took this is 0.8, but actually we have right 0.85. Okay, sorry, my mistake. So here is 0.85. Yeah, so yeah, maybe someone remind me if I have some mistake. So this one is minus 31.78. Okay, yeah, anyway, yeah, so if I just conclude here, so if power factors lagging is 0.85, you can get IA is what? How many? Yeah, just accept the values 25.8 with minus 31.8. Yeah, 25.8 with minus 31.8 degree amperes, and we have EA E 182 with the phase angles minus 17.5 degree watt. Okay, so anyway, this one the blue color for 0.8 lagging and the red color for 0.85 lagging. Okay, so now you can draw the phasor diagram, right? Here we have V phase, that's a 208, which is 0 degree. How about IA? This is lagging with minus 31.8 degree. So here is IA. Okay, and the fixed angle here is 31.8 degree. Okay, so we can get the EA, right? So this is lagging, yeah, perpendicular. So here is EA is 17.5. So here is EA, yes, EA E 182 with minus 17.5 degree. Then this one is J is XSIA. Okay, yes. And this phase angle is 17.5. So here we have the conclusion. We have theta is 31.8, and then delta is 17.5. So we have Raymer how many? 31.8 minus 17.5. So we get 14 here. Raymer, this is 14.3 degree. Okay, yeah, this is question A. Now question B. If the motor flux is increased by 25%, sketch the new phasor diagram. What are EA, IA, and power factor of the motor now? Okay, so that means now we increase 5M. How many percent? 25%. That means now 5M overcomer is 125 5M because we increase 25%. So totally we have 125% of 5M, right? So we can get EA new is 125%. 125% of EA, right? I mean magnitude. Okay, so we can get EA new now 1.25 because 125% is 1.25 times how about magnitude? Okay, magnitude is 182. So 1.25 times 182, so you get 227.5 amp. Sorry, volt. Any question, please, so far? Any questions? Maybe I ask someone. Hoàng Nghĩa, any questions?
No, don't have any questions.
Okay, so come back. Thank you. So for now, we have magnitude of EA overcome E 227.5. Okay. Yeah. And P in E fixed. P in E fixed. If we follow the theory, P in E fixed. So that means we have P in overcome E, P in E, how many? Yeah. Yeah. 13675. 13675 watt. Okay. So if we follow the theory, remember when we increase IF, that means for lagging, right? For lagging, when we increase IF, that means we reduce IA. We reduce IA. This is the theory, right? Of course, when we increase IF, that means we increase the magnitude AA. But AA decrease. Why? Because B in E3, we find EA sine delta divided by XX. Okay, this is constant, right? This is constant. This one constant. This one constant, right? So when we increase EA, that means we decrease sine deltas. Okay, so of course, so when IF increase, EA increase, and delta should be decrease. Okay, this is the theory. The theory. And of course, JXSIA increase. Decrease or did it decrease, right? Because IA decrease. Okay, they decrease. Yes. Okay, so now we can calculate. So now B in E3 V5, right? Now we have EA overcome new because we increase. Because when we increase 5M, right? That means we increase EA, right? Yeah, here. Okay. Yeah. So now we have sine delta overcomer, right? Divided by XS. Okay, so now we have sine delta overcomer B in the 13675. Yeah, time we face a 208 and EA overcomer how many? And now we have 227.5 and then we over XS is 2.5. Yeah, you can get the answers. Okay. So 13675 times 208 times 227.5 divided by 2.5. Hey, oh sorry, my stupid. So here should be what? B in time 2.5, right? Yeah, and divided by 3 times 208 times 227.5. Sorry. So 13675 times 2.5 divided by 3 208 and 227.5, we get 20240.8. That means you can get delta overcomer, right? So now delta over gamma is 13.9 degree. Okay, so now we compare. Okay, compare. So at the beginning, theta how many? At the beginning, theta how many? Here. Okay, minus 17.5. Okay, yeah. So that means that means, yeah, 17.5 degrees. So now we have delta over gamma is 13.9. Okay, so this is similar to the theory, right? Yeah, delta degrees. Here, degrees. Okay, now continue. After that, we can calculate what? Go back. So we need to calculate EA, IA, and the power factor, right? So now, yeah, we can calculate. So we have V phase EA plus JXSIA because RA is 0. So you can get IA over gamma E. V phase minus EA. So V phase how many? 2, 0, and A with 0 degree minus EA. EA we have how many? Here, 227.5. Okay, 227.5 with the phase angle minus 13.9 degree. Yes, minus 13.9 degree divided by 2.5J. Okay, yeah, now you can see, yes, yeah, 13.9. Okay, yeah, that's correct, 13.9. So you get how many? 0.0 and A with the phase angle 0 minus 227.5 with the phase angle minus 13.9. Okay, then divided by 2.5J. So we get the current is 2.46 with plus 13.2. Something wrong? No. Degree is A4. Okay, so now we can check. You get the 22.5, right? With plus 13.2. So now look, now the phase angle is positive, right? The phase angle is positive. That means this one is leading. Okay, leading. Yeah, so we have delta connection, so we have IA times square root of 3. So you get 22.46 times square root of 3. So you get 38.9 ms. Okay, so now we have EA, and okay, so now we have the phase angle. Okay, we have theta now 13.2, but this one is leading, right? We have deltas is 13.9. Okay, and we can get the Ramer is the phase angle between IA and EA, right? Yeah. And for IA, this is 13.2, and EA you get the phase angle of EA is 13.9. Okay, so here you can get EA over 227.5 with the phase angle minus 13.9 degree. What? Okay, so now we have the difference between the phase angle of EA and the phase angle of IA. This is 26.5. Okay, yeah. So now we can draw the phasor. Okay, now for this case, IA how many? IA how many? IA 22.46. Okay. Okay, so here this is lagging, this is right. IA E 22.46 with how many? 13.2 plus 13.2. Okay, how about EA? Okay, so here, right, and EA is bigger. Okay, so you get it one. Yes, and EA how many? Okay, and you know, so this one is EA, right? Yeah. So this one is B, you know, proportional to B is constant. Okay, so that's mean and here, you know, this one is proportional to B is a constant. So here we can get EA new here. This EA new, right? EA new, and this one is and this one is JXSIA over comma. Okay, yeah. Now, and this phi angle how many? This phi angle how many? EA here minus 13.3. So here minus here you get minus 13.3 degree. Okay, yes, yeah. So you know, so if we come back to the theory, you know, here, you know, we have EA, and this one is EA over comma, you know, and you should remember the power is constant because we fix the input power. We fix the input power. Okay, so that means EA will be sliding. Okay, we slide on this axis, right? Okay, and here you can get trace XSIA should be here, and this one is trace XSIA over comma should be here. Okay, yeah, and you know, this is IA over comma. So this one like V sharp. Okay, V sharp. Yeah. Yes. Okay. So now we come back here. Yeah, you can draw the relationship between IF and IA, right? IF and IA. So here you get IF. Sorry, here you get IA. Yeah, and here you get IF. Okay, so this one is power factors is 1. Okay, so if IF 4.0, you get how many? You get IA is somewhere here, right? You get how many IA? 25.8, right? 25.8. Okay, so when we continue to enrich IF, so somewhere here, okay, so you get IA new. How many IA over comma is here? Here. Okay, 20 here. 22.46. Okay, so now we have the curve. So the curve like this. You know, this is like it, and this one is leading. Okay, so this one we say V curve. Okay, yeah. So for we can guess IF here maybe 8.0 amperes. Yeah, something like that. We don't know because we don't have any information about IF. But I think that maybe this one is 60.5 ampere. Okay, yeah. So this is V curve. This is V curve. Okay. Yeah. So we finish. Yeah, we finish example, and of course we can use the MATLAB to draw the VF curve. Okay, so this is the VF curve come from MATLAB software, and you can see if you get 4.0 ampere IF, this is IF, and this is IA. Okay, so you get here, follow the theory, this is 25.6 ampere, right? Okay, so for and then this one is this is the minimum point. Okay, that means here BF is 0 or unity power factors. This one is lagging, right? And this one at the left side for lagging, and at the right side here for leading. And for leading we have 22, right? 22 by what? 22 by 46. Okay, so if we have 22 by 46, so somewhere here, right here, so you can get IF now is 5.2 amperes. Okay, yeah. So we come back to this figure. So now E not 6. This E not 6, right? It's A. This one is how many? 5.2 amperes. 5.2 ampere. Okay, so for in the lab, Mr. Hill will guide you how to do the experiment of synchronous motors and how to draw the V curve, of the effect of field current. Okay, yeah. So we finish example 2, example 3 for your reference. We don't have enough times. Okay, and yes, for example, example 3. So in the afternoon we will continue. Okay, so now the summary before we stop. Okay, so remember that for any characteristic torque speed curve of synchronous motors, we have two cases. Okay, first of all, IF fixed, right? And we change the input power. Okay, change. Okay, change. We say the effect of load change. Okay, so the second case, we in fix, and then we increase IF. Okay, so when we increase IF, that means we increase phi m, we increase the magnitude of AI, and delta decrease. Okay, delta in the phase angle between V phi and AI. Okay, yeah. So this is the effect of what? The effect of field current change, and this is the effect of load change. Okay, and for this one, for this case, okay, we can get the V curve. This is IF, This AIA, right? And this one is BF is 1. So we get the vehicle like this. Okay, so this one for lagging and this one for leading. Okay, so that means for lagging, when IF increase, IA decrease. For leading, IF increase, IA increase. Okay, yeah. So if we have different B, we have different curve like this. Okay, different curve. Okay, so this one we say V curve. Okay, that's all. So yeah, we finish the lectures in the morning, and yeah, see you in the afternoon. Any question, please? Any questions? Thứ ba. Okay, so we stop now. Vậy là thứ ba sẽ gửi với thầy